So all we're going to do here is we're going to take some of the basic ones we did in lesson 7.1, okay? And we're going to transform them, knowing our rules. Should be on the far right. This one we know. Remember what I said? Negative 1, 0, 1. So 2 to the negative first gives me what? 1 over 2. 0 is going to be 1. 1 is going to be 2. That's enough. So negative 1 is 1/2. 1, 2. Well, it's a little tight. Yeah. Okay. Don't forget the asymptote as part of your graph. Okay. So that's a complete graph of y equals 2 to x. We did that one without having to do a table of values. Or, I mean, we could do a table of values. We could just do mapping notation. How would you graph this one? It's 2 to the x, but what? Sorry? Change it to this, please. Change this one to y. Change all 3 of them to these ones, please. I thought I corrected it. So first one is y equals 2 to the x. Second one is y equals negative 2 to the x. Third one is y equals 2 to the negative x. Yeah, I did. I thought I had done it in the exercises, but clearly I haven't. Okay. So this is 2 to the x. This is 2 to the x. What? What does this do? What does this do to any function if there's a negative in front? Flips it how? Yep. Right? So this is y equals 2 to the x flipped vertically. So I really don't even need a table of values because I've already got the graph down there. So all I have to do is take all these points and flip them over the x-axis. Well, this is 2 above the x-axis, so it flips to 2 down. This is 1 above the x-axis vertically, so it flips to 1 down. This is half above, so it flips to half down. So it's going to look like this. And the asymptote is not going to change. Still going to be the same asymptote as the other one. How about this one? You want to do a whole new table of values, or can we take a little bit of a shortcut? It's y equals 2 to the x, and what's happening to it? Flipped horizontally, so over the y-axis. So flipped horizontally. So go back to the purple one and flip it horizontally. So now we've got to think how far it is horizontally away from the y-axis. This is 1 to the right, so when we flip it, it goes 1 to the left. This is right on the y-axis, so when we flip it, it stays where it is. This is 1 to the left, so it goes 1 to the right. And this is what our graph looks like. With, again, the same horizontal asymptote. So as long as you know the original one, the parent function, the mother function, whatever you like to call it, okay, you can do transformations on it like we've been doing all year. What does A do to a function? What does the number in front do? Two things. Flips it if it's negative, and if it's a number here, stretches it vertically times by whatever that number is. B, if it's negative, flips it horizontally. But if there's a number there, then it stretches it horizontally by, what do we times it by? The reciprocal, 1 over B. What does this do? Shifts it left or right, horizontally. This shifts it up or down. Okay. So let's just look at a couple of examples. I put 2 in here. We don't need to use 2. We don't need this. Okay. But I've set these up for mapping notation. So we know that those are the points. What does the -1 do to the coordinates on the original? It what? Shifts it. Which one? X or Y? X or Y? Y, down 1. So basically, we've got to just take every Y value in this one and subtract 1. So -1 would be 1/2 minus 1, which is -1/2. 0, 1 would become 0, 0. 1, 2 would become 1, 1. So -1, -1/2, 0, 0, and 1, 1. What happened to the asymptote as well? Did it move? Yes, it shifted down 1. So it's not on y equals 0 anymore, it's on y equals -1. So once you get your asymptote in, you should be able to sketch the graph. Okay, we've got a curve going on here, and we've got the left-hand side heading towards the asymptote. Little practice with some properties. What's the domain of this? Left to right? Negative infinity to positive infinity. What's the range? -1 to infinity. What do I put around the -1? A bracket or a parenthesis? Because I don't include it, it never touches. It doesn't start at -1, it starts just above -1. What's the x-intercept? 0. What's the y-intercept? Sorry, 0. It's set on 1. 0 and 0. Good. Okay. Next one. Again, we don't need that. Save ourselves a little bit of time. Mapping notation. Oh, first of all, sorry. So 3 to the x gives me -1, 1/3, 0, 1, and 1/3. Only one transformation is happening in here, and it's a negative, which means it's a flip. Which flip is it affecting, the x or the y? The x. X, because it's horizontal. Horizontal is the x-axis. So y is not changing, but every x is becoming negative. So that means we get 1, 1/3. -0 is still 0, 1. And this becomes -1, 3. So to graph these, 1, 2, 3, 2, 3, 3, and 1, 2, 3. I've got 1, 1/3. I've got 0, 1. I've got -1, 3. Only time the asymptote will change with exponential is if there's a vertical shift, like we did in the first example. If there's no vertical shift, it stays always on the x-axis, y equals 0. It'll always stay there. And that's our graph. Okay. And again, some properties. We can see that the domain, again, is going to be -infinity to infinity. This time the range is going to be 0 to infinity, but a parenthesis around the 0. X-intercept? Nope, none. Doesn't cross the x-axis. Y-intercept is 1. Okay. Okay. Let's have a look at this one. So we've got 1/2. A fraction as the base now. Don't let that fraction as a base throw you. 1. Remember, 1/2 to the -1 is the same as flip the base to the +1. So that becomes 2. 1/2 to the 0 is still 1. 1/2 to the first is 1/2, and we don't have to do this one. Couple things happening on this one. So what's happening? Is anything affecting the x's? Yes. It's going, they're all going 1 to the right or left? To the right, which means positive. So even though it says x minus 1, it's moving to the right, which means we're adding 1 to every x. The negative in front tells us that we flip the y values or change them from positive to negative. Sorry, change the signs of the y values. I shouldn't say flip. So no vertical shift, so I know that's not going to change. The only time it changes is if there's a vertical shift, something at the end. So I've got -1, 2. 0, 1, 1, 1/2. The asymptote is still the x-axis, or y equals 0. And it's going to look something like that, although technically it should be a little bit more like that. Okay. So I'll just put these ones in. That became, oh, sorry. What am I doing? I didn't even finish the question. Ignore that. That's the original one. This becomes 0, -2. This becomes 1, -1. This becomes 2, -1/2. There we go. I was just jumping way ahead of myself. So 0, -2 here. Come on. 1, -1, and 2, 1/2. So it's going to look like this. Sorry. Domain, again, is going to be everything. What's the range going to be in this one? -infinity to 0, not including the 0. X-intercept doesn't cross the x-axis. Y-intercept, -2. You see that from the graph. Okay, and the final question. Again, sometimes these may pop up. You just got to keep track of your transformation rules. Remember, when we describe flips and stretches first, shifts at the end. So stretches, see any negatives out in front of the entire function or the x? Nope. So no flips. Stretches, what kind? Vertical stretch. And remember, when we talk about stretch, we have to use the word factor, which means multiply. Vertical stretch, factor of 3. So we've done this. No more stretches, so now we're just to the shifts. You never shift by a factor. Okay, factor means multiply. That only applies to stretches. So there's a horizontal shift. How? 4 units left. And there's a vertical shift. 2 units up. Yeah. Let's hope for one of these on the provincial. Because like this one would be 3 marks. And if you know your transformations, which I hope you do because we've been doing them quite a bit, should be a straightforward 3 marks.